Valve sizing basics. What is pressure drop? In process control systems, fluids naturally flow from areas of higher pressure to areas of lower pressure. As fluid moves through piping, equipment, and valves, that pressure gradually decreases. This reduction in pressure is called pressure drop, sometimes referred to as pressure loss. Pressure drop is a key parameter when selecting and sizing control valves. In this video, we'll define pressure drop, show how it's calculated, and explain why it matters in flow control systems. At its core, pressure drop is simply the difference in pressure between 2 points in a flowing system. For a control valve, that means the difference between the inlet pressure and the outlet pressure across the valve. We typically call this difference delta P, and the calculation is simple. Delta P equals P1 minus P2. Pressure drop is usually measured in pounds per square inch differential, or PSID. To calculate pressure drop accurately, we don't just measure anywhere, we measure at specific locations in the pipe. The inlet pressure, or P1, is typically taken 2 pipe diameters upstream of the valve. The outlet pressure, P2, is measured 6 pipe diameters downstream. These values are usually provided by the process or instrumentation engineers designing the system. Let's look at a simple example. If the upstream pressure, P1, is 300 pounds per square inch, and the downstream pressure, P2, is 200 pounds per square inch, then the pressure drop across the valve is 300 minus 200, which equals 100 pounds per square inch differential. Now, if the flow rate changes, those pressures can change too. So pressure drop often needs to be evaluated across multiple flow conditions. So why does pressure drop happen in the first place? Because flowing fluid always encounters resistance. That resistance can come from several sources. Friction between the fluid and the pipe walls. Changes in direction, like elbows and fittings. Restrictions, such as valves or orifices. And turbulence caused by changes in velocity. All of these effects convert pressure energy into heat and turbulence, which results in lower pressure downstream. Control valves actually rely on pressure drop to do their job. As the valve closes, it creates more restriction in the flow path. That increases the pressure drop across the valve and reduces the flow rate. When the valve opens, the opposite happens. Restriction decreases, pressure drop becomes smaller, and flow increases. So, in simple terms, flow through a control valve depends on both valve position and pressure drop. Pressure drop is also a critical input in valve sizing. As we covered in our video on CV, the flow coefficient relates 3 key variables: flow rate, pressure drop, and fluid properties. For a given valve and CV value, the amount of flow depends directly on the available pressure drop. That's why accurate pressure data is so important when selecting a control valve. Pressure drop also plays a major role in valve design and selection. Higher pressure drops may require specialized valve designs, trim configurations, and materials. Manufacturers define maximum allowable pressure drop limits for their valves. These limits indicate how much pressure drop a valve can handle while still operating reliably. For example, globe control valves often handle higher pressure drops due to their robust internal construction. Some rotary valves, on the other hand, may have lower limits, because high-velocity flow can place significant stress on the disc or ball segment. Understanding pressure drop is essential when sizing and selecting control valves. At Trimteck, our engineers work closely with customers to evaluate process conditions and deliver valves designed for reliable performance. Visit trimteck.com to learn more, or reach out to our engineering team for help with your next application. And don't forget to like, subscribe, and click the bell for more valve sizing basics. See you next time.